Welcome. So this lesson is prep for Skill 15. Okay? And in Skill 15, we're going to have to simplify square roots. All right? In the past, we've just left them if they're not a perfect square, but there's something called simplest radical form, where we take out any perfect squares that might exist. Okay? So here's how we're going to do that. Looking at square root 20, we're going to think about 20 in some different ways. And you might have done this in a previous math class where we think about what's called prime factors. All right? So I'm going to make a huge square root just to remind myself that I'm still taking the square root of this number. And I'm going to write 20 as any pair of factors. All right? I'm going to do 2 and 10. All right? 2 times 10 is 20. So I can write it like that. Now 2, the only factors of 2 are 2 and 1. So I'm done there. But 10, I can think about as 2 times 5. Okay? And now these three numbers, 2, 2, and 5, are all prime numbers, which means they don't have any factors except 1 and themselves. Right? In other words, there's nothing I can divide them into besides 2 and 1 or 5 and 1. Okay? So now that I have my factor tree, I'm looking for pairs of factors, right? Because I really could write 20 as 2 times 2 times 5, or I could write it as 2 squared times 5, right? And when I'm taking the square root of 2 squared, right, that's just going to give me 2. So if I have a pair, like I have 2 2's here, we're going to bring that 2 out front of the square root. And notice it's not 2 squared anymore. It's just 2 because the square root and the squared cancel. And then I have 5 underneath. So we say the simplest radical form of square root 20 is 2 square root 5. Okay? Let's look at another one. So square root of 32. I've got 32, and you can split it into any factor pair that you want. I'm going to do 2 and 16, and then I'm going to do 4 and 4. All right, and now I see, like, I could do 4 as 2 and 2 and 2 and 2, but if I think about 32 as 2 times 4 times 4, all right, well, that's 2 times 4 squared. All right, that 4 squared can come out front as just plain old 4, because the square root of 4 squared is 4, and I'm left with 4 square root 2. Okay, so I have those 3 prime factors there. Okay. And then 84, square root of 84. I know 7 times 12 is 84. Let's see, 7, that's a prime number, so I don't have any factors to write there. 12 is 2 and 6. 2 is a prime number. And then 6 is 2 times 3. So now I've got 7 times 2 times 2 times 3. My 2's pair up, so I'll bring a 2 out front. And I have 7 and 3 left in underneath the square root. So it's 7 times 3. So I'm going to write it as 2 square root of 21. Again, if you didn't see that, we had 2 times square root of 7 times 3, which we simplified as 21. Okay. I'll leave these 3 for you to try on your own. Your answers, though, to check, you should get 2 square root 30, square root 30, and 3 square root 11. Notice this one in the middle. Right? 30 seems like a big number, and it has factors. Like I could do square root of 30. I could write it as 6 times 5, and then I could write 6 as 3 times 2. Now I have my prime factor tree, but 3, 2, and 5, I don't have any that are matching that I could bring out right in the square root. So square root of 30 cannot be simplified. Okay, then one other wrinkle that could be in there is if we have variables. Okay, so the thinking is the same. So if we look at 75x squared, right, well, x squared, I could write it as x times x, but then I would just pair them back up. So I know x squared I can take the square root of that. So that would just be x out front, and now there's nothing left there with the variable. And then 75 works just like we did up top. So I know 5 times 15, 5 is a prime number, 15 is 3 times 5, and then I've got 5 and 5, so it's 5x square root 3. In the middle one here, x to the third, I've got x squared. I'm looking for x squared, but I have one more x. All right, so that x squared I can bring out front as an x. All right, and then I just still have an x under the square root, and then 24, if we split up, I'm going to split it up into 4 times 6. 4 is 2 times 2. 6 is 2 times 3. Those are all prime numbers. 2 of my 2's come out front as 2x, and then underneath the radical I still have 2 times 3, so 2x square root 6, and then I have the x in there still. And this could be problems like this with any number of variables. So square root of 126, x to the 4th, y to the 5th. If I think about 126, ooh, I don't know. I know that's divisible by 2 because it's an even number, and it's 2 times 63. Whoops, 63 is not prime, so I shouldn't circle it. That's 63. And then 63 is 7 times 9. 7 is prime, 3 and 3. So my 3's can come out front as a 3. 2 times 7 is 14. And then my variables, we have x to the 4th, y to the 5th. X to the 4th is x squared and x squared. So I can cross those off and bring out x, and then another x makes it x squared. Y to the 5th is the same thing, y squared, and y. Can take out 1y, 2 y's, and then there's a y still in there. So if I write that all up here, we have 3x squared, y squared, square root of 2 times 7 is 14y. Okay. As you do this more often, you'll start to see some patterns and maybe some ways you can think about it a little more quickly. But I like the factor tree method because you can always get started as long as you can find factors of that number. Okay. So try that practice, and if you have questions, you can rewatch the video again.